Okay, this video is all about the problems of burning fossil fuels. Now, fossil fuels are those that come from things like crude oil, from coal, and from natural gas. And probably the simplest one to look at, because it's one you use quite regularly in chemistry lessons at school, is methane. Methane is the simplest hydrocarbon. And if you remember, hydrocarbons are compounds that contain only carbon and hydrogen. So there's methane. When we burn methane, we react it with oxygen. And we get, as our two products, carbon dioxide and water. Now, you never actually see the water when you do a straightforward chemistry experiment because the flame is hot, so the water comes off as a gas. And water vapour is invisible. It looks just like any other gas, like oxygen or nitrogen in the air, so we never see it. Now, first of all, we haven't balanced this equation because there are 4 hydrogens in methane gas, so we need 4 hydrogens in our products. Water has only got 2 hydrogens in it, so we must make 2 molecules of water. 4 hydrogens on the left, 2 lots of 2, that's 4, balanced. Now, oxygens, we've got 2 molecules of water, each one has 1 oxygen in, 2 ones are 2. There are also 2 oxygens in carbon dioxide, that makes 4 oxygens, so we must have to start off with 2 molecules of O2, 2 pairs of 2, which is 4 oxygens. So now that's balanced. Now, water, as we know, is pretty harmless. Carbon dioxide, however, causes problems, and you are probably aware of the fact that carbon dioxide is a greenhouse gas. That means that its effect on the earth is a bit like the greenhouse in someone's garden has effect on the temperature within it. Carbon dioxide lets through sunlight from the sun, and that warms up the Earth's surface. The Earth, being warm, then gives out heat radiation, and carbon dioxide is very good at absorbing heat radiation, so it warms up. It warms up the Earth's atmosphere. And so that's what, in excess, leads to global warming, or climate change, some scientists prefer to call it these days, because global warming, parts of the Earth warm up, other bits don't. Okay, so that's the main problem with burning a fossil fuel. Carbon dioxide is being produced in very large quantities. But there are other problems. Supposing you don't get enough oxygen into your reaction mixture to burn the methane completely. Now, the example of this happens when you set your Bunsen burner on the safety flame, the visible flame. The fact that you can see a yellow flame tells you that there's not quite enough oxygen there. To get more oxygen there, you open the air hole, and sure enough, the flame burns hotter and you get a more vigorous reaction. But when you don't have enough oxygen, you get this visible yellow flame. And if you heat things up with this yellow flame, you will notice after a few minutes of heating something, it has a black coating of it. And that black coating is soot. And soot is very small particles of solid carbon. Now, let's balance this equation. There are 4 hydrogens in methane. That means we still have to make 2 lots of water. But in this equation, we only start off with 1 molecule of oxygen, 1 pair of oxygen atoms, for every molecule of methane. And so we haven't got enough oxygen to make carbon dioxide like that. We only get soot. Now, that soot can cause another problem. Soot, apart from actually it being very bad for your lungs, you don't want to breathe in too much soot, but it causes a wider problem, which is known as global dimming. Soot in the Earth's atmosphere actually blocks out a tiny amount, a small percentage of sunlight reaching the Earth. If we had a very sooty atmosphere, the temperature on the Earth would actually be quite a bit lower because the sun would not be getting through to warm up the Earth's surface. And that is known as global dimming. There's a further problem when we burn hydrocarbons like methane. If we have a little bit more oxygen than just 1-to-1 ratio, let's say for every methane, on average, we have 1.5 oxygens. Obviously, you can't get half an oxygen, but if the ratio is 1 to 1.5, so it might be 2 to 3, whatever. Then you get another problem. You see, your 4 hydrogens will still end up as 2 lots of water, but the carbon will react and gain just 1 oxygen, and that produces carbon monoxide. Called monoxide, you can see the mono there, 1 oxygen atom. And this is very poisonous. And every now and again you will hear stories of people who've been poisoned by carbon monoxide in their own homes because they have a gas fire which they perhaps leave on overnight, and because of poor ventilation, not enough oxygen gets to the methane gas. It doesn't get 2 molecules of oxygen for every 1 methane. It only gets 1.5, and that produces some carbon monoxide. So very dangerous to leave gas fires on all night long. When we work in a chemistry lab, when you see that Bunsen burners on the safety flame, a small amount of carbon monoxide will also be produced. And in the long term, that's not very healthy. But you only use Bunsen burners for a short while in a lesson normally anyway. So it's not a problem to you and I. In large quantities, it's very poisonous and it can kill people. So there are all the problems of burning a pure hydrocarbon such as methane. However, as if that isn't bad enough, there's one other major problem, and that is that many fossil fuels, and the worst culprit is coal, but it applies to all of them, many fossil fuels contain sulfur. When you've been to a petrol station, perhaps you may have pulled up against one of the petrol pumps, and alongside the diesel pump, it sometimes says low sulfur diesel. Diesel oil that's been specially purified to remove most of the sulfur. But sulfur is quite a common impurity in most fossil fuels, and that causes a problem as well, because sulfur is very happy to react with oxygen when the fossil fuel burns, and that produces sulfur dioxide. Now, sulfur dioxide is a very nasty gas. It's poisonous in small, quite low quantities. It's got a quite strong smell, so you can detect it fairly easily. But it's poisonous. It can cause breathing difficulties, especially for people who are asthmatic. It's one of the main causes, or it was one of the main causes of death in cities in wintertime, back in the 1950s, when most people were burning coal in fires in their own homes to keep their houses warm, and all the sulfur being produced was going up into the atmosphere. And if you had a particular type of weather where there was very little wind and it was very still, you got sulfur dioxide building up in huge amounts in the atmosphere, and people were being rushed to hospital with severe breathing difficulties. And it was actually quite a surprisingly dangerous chemical. Thankfully, these days, people don't burn much coal anymore, and one of the reasons is because of the danger of sulfur. Now, it does cause breathing difficulties on a local level, but on an international level, across the world, it causes another problem, because sulfur dioxide, when you react it with water and also a little bit more oxygen, half a molecule of oxygen for every molecule of sulfur dioxide, you end up with sulfuric acid. Now, sulfuric acid is a very strong acid, so you don't need much of that to make the atmosphere a little bit acidic. And sulfuric acid also dissolves very well in water and leads to acid rain. And acid rain is still a problem in some parts of the world where there's still a lot of coal being burnt. The acid rain falls on forests and so on. It destroys trees, and there are examples in Scandinavia and in Russia where forested areas have been seriously damaged by acid rain. It also acidifies lakes and rivers, and it can kill water-based life, so fish, prawns, whatever might be living in a stream, they can be killed. So sulfur dioxide is a big problem. The main significant global problem is acid rain, but on a local level it does also cause breathing difficulties because it's poisonous. Okay, so those are the main problems of burning fossil fuels.